James Wallace. This is Matt Hackner, William Chen, and Andy Lee. And our toy is the marble launcher. So, an introduction to our project. We first were looking at different ways to launch projectiles. We wanted to make something that wasn't lethal, so something that kids could use, but and shoot a target, but wouldn't inflict a lot of pain. And so we found some things on the internet using rubber bands, but we decided to use springs because they're more, they're better for engineering. Elastic is hard to predict where it's going to go. Okay, so yeah, our target audience was ages 18 and plus once we came out with the design because of how fast it was going to launch a marble. We didn't think it was suitable for ages below 18 years old. And the design is supposed to be cost effective. It is medium size, it's not a smaller launcher, and it does have some weight to it. It's not necessarily light. And we wanted to have the ability to launch a marble at roughly 60 feet per second. So our sub-assemblies, we have the cocking mechanism, which is a racking pinion that'll bring the slider back. The loading mechanism, which is back here once. And that'll allow the slider to stay in place. And the trigger mechanism is once you release this, it'll fire this. And the frame was laser cut out of the acrylic. Now I'll pass it over to Matt, who's going to go over the cocking mechanism.
Okay, so as he mentioned, the cocking mechanism is pretty simple. Essentially, it is a rack and pinion gear system. Now, both the rack and the pinion gear were 3D printed using models of a 20-degree spur angle rack and pinion gear system. And so the geometry involved, the pinion gear is just a pinion gear, but has a keyed axle in it that makes it so when you turn the crank, it also will turn the gear. Then the pinion gear, the notable geometry is we have this void, which was just to cut down on material usage, as well as a curved track for the marble to actually travel down and increase accuracy a little bit, rather than if it was just a hard stop for the sled cut. This should be the animation. So the animation and the actual action of the thing came out very close. The gear handle has to be rotated about 320 degrees for a full motion, and it needs to be rotated back before it can be fired.
So for the loading mechanism, we decided to use a PVC tube, and it will be placed. It should have been placed directly on top of the trigger mechanism, and we made a lever switch that if you push it down, it should push the marble through an opening, and that opening should be covered by a soft plastic that will hold the marble in place, but to allow the marble to go through it. And the thing is, like, we had a small tolerance issue, and the rod doesn't really go through the hole that well, and we decided not to fix it. Here's the video of it working. And one side is blocked, and the marble sit on top of it. Push it down enough. Dylan will talk about the trigger mechanism.
So I worked on designing the trigger mechanism. I don't know how many of you guys are hunters, but this is modeled very similar to a typical crossbow trigger mechanism. We've got 3 components, what we call the trigger bar, which is pinned, we call the wheel, which is pinned with 2 slots cut in it, and then what we call the sled. The sled is actually what holds the marble. As Matthew talked about earlier, there's a little bit of a groove here in the rack, and there's a similar geometry inside the sled, which is concentric with that, so that kind of forms the lower surface of our barrel for this project. So the marble actually sits in this cup. Sled is directly driven by these springs. They are actually attached right here with little eye bolts. So there's always pressure on this wheel, and when the trigger bar is released, the wheel rotates, releasing the sled. So I'm going to show you the animation for that.
Okay. So the last piece is the frame, which, as I said before, is laser cut out of acrylic. And the way we made the frame was we designed all the other components, and then at the end just drew a frame around it. We were able to get all the coordinates and everything match up. So it wasn't too hard.
So you guys have seen the final product now, and several virtual models of our project. But we had a few issues which may not be immediately relevant to what you can see here. Andy talked about the tolerance issues with loading mechanisms, so we weren't able to get that to operate properly with the rest of the project. But I don't know if you guys can see it here, but this bolt right here, we actually had some stress issues. We didn't do a stress analysis. So this bolt right here supporting the front end of the springs is actually bending. It's causing a little bit of issue with front of our net binding. On top of that, the acrylic frame was a little more brittle than we had anticipated, so we're actually experiencing cracks in the frame as well, just from the impact of the sled to the front of that rack. But overall, the mechanism still works as it should.
Here's a video of our prototype.
And so the final product operates pretty much the same. And that is our product. Well, for a younger child, for someone as grown as us, it is a little bit shorter than a typical grip for a rifle-style projectile launcher. The one thing that would be changed for a younger audience would be grip would have to be a little bit thinner here. I do actually have small hands, so at a target age range of 18 plus, that it's actually fairly well sized. In the front, it's 10 inches long because that is the ideal way for us to get the maximum amount of stretch out of the spring. Since these springs are rated at 10 inches in their non-stressed state and plus 11 inches for their fully stretched state. It will work, it won't have as much firepower.
So how hard, if you take a marble at 60 feet per second, shoot it into somebody's face, how much damage does that do?
It would probably
Soccer ball at 90 meters speed a second is enough to touch a soccer player.
Right, it will not do nearly as much damage. This is intended for the same kind of, it's not meant to be, shot at your friends. It's meant to be shot at targets.
It's going to happen.
Well,
so liability,
true.
how much of that damage is going to do?
We gotta take that into account.
Yeah, we didn't take that into account, but BB guns would still be a lot more deadly or damaging.
Not so much, they're much lower mass, so momentum is much, much lower.
Well, the mass of the marble is about the same as the mass of a large BB.
Maybe a metal one, not a lot.
Yes, a metal one. I'm referring to that as, a BB gun, not an airsoft.
So this could kill a squirrel. what you're saying.
This, in its current state, it would
If
not
it was
be able to.
accurate enough.
No, it's
Okay.
And the design parameters were 60 feet per second, but actually when shooting the marble, there's a lot of friction, and so we're not.
Assuming everything was proper.
Yeah, so it would be more, it would not be the same.
It's okay.
So can you walk through the design process from saying that you want 60 feet per second out of barrel velocity to selecting like the spring or designing considering
I think
stresses?
what happened was when we were doing our research for this, we kind of wanted to model it after a slingshot, so your typical slingshot shooting crossbow. So that was about the ballpark velocity that we were seeing out of handheld slingshots. We honestly made some of our decisions on velocity based on what springs were available. We had looked at springs that were the proper size for the physical dimensions that we wanted out of this product. But we also did realize that there were probably going to be a lot of friction issues. I don't know if you can see from there either, but the sled that actually holds marble, those tolerance issues, there's a little bit of extra gap there than we would have liked. It wobbles a little bit as it goes down front to back. So we lose a lot of our energy through that interaction. And we figured there would be a little bit, so 60 people per second, we didn't expect to actually see that.